through this, in a lot of ways, a lot slower than we normally would, because normally I would lecture for a full day and then throw the homework at you. And then the next day we go over the homework and I'd have to lecture another day. And a lot of times I'm having you take a lot longer to get through this. So we actually are not moving as fast as we could be moving. Okay, so answers to your homework questions. Let me pull my book out here so I can see what the questions are. All right, number 1, what is an electrical current? That is a flow of charges. I'm not going to take a lot of time with this homework, but I'll try to make sure you know the things that I think are important. Some of these I think were straight out of the notes. What carries current in metals? Those would be free electrons or unlocalized electrons in metals. Remember metallic bonding? What is the difference between conventional current and the physical movement of charges in a conductor such as a metal? And of course, electrons flow from negative to positive, whereas conventional current flows from positive to negative. Yeah, get that straight. Electrons are negative, so they're on the negative side and they flow to the positive side because opposites attract. Conventional current is flowing from high to low, which is from positive to negative. Okay, so they go opposite each other. Sorry. In what kind of current do the charges move in only one direction? And of course, that is direct current. We talked about that today. When installing a battery on your calculator, how do you know which end has the electrode with the higher potential? And you look at the markings on the calculator. The calculator will have a plus sign. I should have put that in the answer. Has a plus sign to indicate the higher potential, because positive is higher than negative, of course. Okay, I'm not sure that I gave you the right sections to get these answers, but they were in your book, section 20.3. Yeah, you were supposed to read that, so you should have gotten these, okay. I didn't talk about them in the PowerPoint. List the kinds of devices that convert the following forms of energy to electrical potential. For light, you've got a photovoltaic cell. When I was a kid, I had a Radio Shack electrical kit, kind of like the one they're going to show you in the lab tomorrow. And it had it had little solar cells. I would tend to call these solar cells. You probably would too. Chemical, voltaic cells, primary cells, storage cells, these are your classic batteries. Classic batteries are using chemical. Thermal are called thermocouples, and I don't know that I've ever interacted with a thermocouple in any way. And then mechanical are generators and piezoelectric cells. And generators, of course, are spinning wires. And piezoelectric cells are something else that I don't think I've ever actually interacted with myself. What carries the current in electrolytic solutions? I skipped this in the lecture, but you should have read this in the book, dissolved ions. We did talk about this in physical science. If you have an ion, and in chemistry, if you have an ionic compound and you drop an ionic compound into water, it will separate. The ionic compound will come apart, and then you have positive ions and negative ions, and those positive and negative ions can move around and create electricity. Number 10, discuss the difference between resistance and resistivity. And resistivity is a characteristic of the type of material. Resistance is a characteristic of an object, but both of them measure the ability to oppose the flow of electrical current. So resistivity is a characteristic of the material itself. Resistance is a characteristic of an object made out of some material, okay? So the resistance is for the object, the resistivity is for the material. It's kind of like specific heat is resistivity, and heat capacity would be resistance, if you make that helps you. But they're both measuring the ability to oppose the flow of electric current, which comes out of the word resistance. I think that's kind of, the word is one that actually says something to us. It's kind of normal. What class of materials lack electrical resistance? And the answer is superconductors. And what environmental condition limits the usefulness of this property? And that is they have to be really, really cold. And so it's not necessarily easy to come up with situations where you can use a superconductor because it has to be so cold. All right, true, false. This will go quickly. Charged particles carrying a current in a wire move at speeds near to that of light. And that is false. The impulse moves at the speed of light, but not the electrons. We talked about that. Number 28. At room temperature, every material has some resistance, and that is true. Because remember, superconductors are really, really cold. Okay, if you applied a certain voltage across, this is 29. If you applied a certain voltage across the 1 centimeter thickness of a 1 square meter copper plate, you would discover that it had the same resistance as a 1 centimeter long copper wire. And that is false because they have the same length. They're both 1 centimeter. The distance the voltage is going across is 1 centimeter in both cases. But a 1 square meter copper plate has a much larger area than a copper wire. No matter what the wire is going to have less area. And so they're not going to have the same resistance. All right, well, that finishes this. Don't forget to send me Ohm's first name, and we will continue looking at this chapter the rest of this week. Have a good day, y'all.